Alright, this is a case where I'm going to make a video of creating a mold for this hybrid bridge. So this is a case I'm working with Danny Doming on, and this is the bridge that's been designed in ExoCAD to immediately temporize this patient with. But one of the things he wanted to see if there was some way of creating a flexible mold into which he could then inject his acrylic color of choice or composite material of choice, whatever you wanted to do, bisacryl, any kind of auto cure material that you could inject into this mold, let it set up, and that way have more control over the shade and everything like that, because right now our printing materials are just not all that good looking. So that was the challenge, and so I'll show you what I came up with. I'm mainly making this for Danny's sake, just so he can see it. So first thing I'm going to do is I'm going to select all of this exterior surface, and I'm going to offset it. Now the offset should be by however much you want the wall thickness of these the object to be. So if you want 2mm wall thickness on your mold, then right up here in the top box when it pops up, right here where it says distance, you ought to make that 2mm. Update it, and what that will do is basically inflate an exterior shell surface off of the original bridge, because what we're trying to do is make an outer shell and an inner shell that could be injected. Now the problem with this is that the inner shell is still going to be inside out, right? So its exterior surface is still facing out, just like the exterior surface of the bridge here. And I can show that to you once this gets done offsetting. But basically we want now its exterior to be facing inward. So I'm going to show you what I mean by this. If I go to edit and plane cut, we could look inside of this, and while that looks solid, this is not going to print in a manner that we would be able to inject. You see how that we've got this striped area? That is because right now the exterior surface of the inner half is still out here. We want its exterior surface to be facing inward. Okay, so cancel that. How can I accomplish that? I'm going to go to select, double click the whole exterior shell, but then I'm going to invert, which will deselect that, and it will instead select the whole inner shell. Can't see it because it's inside, but to flip a surface inside out, you would just go to edit now and flip normals. And now if I were to illustrate this again with a plane cut, you can look inside here and see that this is all white surface now. So its outside has now become its inside. Doesn't change the shape or anything like that. It just gives us a better object for the sake of printing. Okay, so now we have this. We now need to make some cuts across this. And so what I'll do first here is I'm going to plane cut this object. So I'm going to make a cut right across this, about halfway up. You see how I'm missing a little bit there, so I'm going to drag this up slightly, right there. And now I'm catching a little bit of this. So maybe I need to reposition this cut just a tiny bit, a little bit lower, and then maybe coming to the same spot here. And that's what I'm looking for. Everything's clean inside, no little tidbits have been missed. So I'll accept that, but this just gives me the lower half of the mold. I need both the lower and the upper half, so I'm going to go up here to export and save this right now. I'll save it on my desktop as lower half of mold. But now I need the upper half, right? So very easy to get that. I'm just going to step it back. And instead of now discarding this upper half, I hit the big fat arrow right here, and now it will discard this lower, leaving me the upper half. Okay, so there's upper half. I can import what I just saved, which is on the desktop, and that's lower half of mold. Now I have my upper and lower molds for this case. Okay, now let's go and make some injection ports. So if he's going to inject in acrylic or bisacryl or something like that, he's going to need an injection port and an escape port where air can escape and then eventually extrude out the material to know that he's completely filled that. So I can do that by coming to Meshmix. I can pull in a cylinder. I'm going to make this 3mm in diameter. Okay, so it's It's 3 millimeters in diameter, but right now it's really short, so I can stretch it. I don't need it that long. Maybe right here. And hopefully you can see now this cylinder is embedded within this right where I want to create a hole. I'm going to accept that. Accept, and then I can also come over while it's already selected and duplicate it, and then push T on my keyboard for transform. Pull it over here, spin it around, and let's make the injection port for this side as well. Okay. So I'm trying to find the ideal spot to stick that. I would say right up in this corner. And I think that will work. Now, it goes without saying, this is really, really undercut everywhere. Unless you put this in a flexible material, you're going to have a really difficult time after you've injected it of getting everything out. So probably the best. All right, sorry I got interrupted by a phone call there, but what I was trying to say is that obviously with this much undercut, you're going to have to print this in a flexible material because otherwise you won't ever be able to get it out. So something like NextDent IBT I think would be a good choice for this. There may be other materials that you could do it with as well. So to create your injection holes, what I'm going to do is I'm going to select first the lower half of the mold and then Control select this, Boolean difference. That will subtract out this cylinder, leaving me a 3 millimeter injection hole. And if you see a failure on this, then you kind of got to go and see what the deal is. So let's cancel that and let's look at this. Okay, so now if I T transform, I need to angle this down just a bit, get it off of that ledge because it did not like something about that orientation. Now Control select, Boolean difference, much better. Okay, and then uncheck auto reduce result, otherwise it'll try to cave that in. So that left a hole. Now let's come over to this one, Control select, Boolean difference, and undo auto reduce, accept. Okay, great. We've got now the upper and the lower half of the mold. Now the shape of this, we're going to end up putting on some articulation pins because right now these are just flat surfaces. Unless you just really index them well together, you're not going to necessarily have them perfectly lined up. So what instead I'm going to do is I'm going to come and use my select tool, and I'm going to select basically the whole underside of this object. Let's clear that. I screwed that up. Okay, try again. I don't want that to go interior to my injection hole, so I can select Shift, unselects, or deselects, whatever the word would be. And I'm just going to capture this whole underside. And remember, this will not select the interior shell. So this is just more or less going to put a flat base. T, transform, drag that up, and accept it. All right, clear that. Now let's go to the top. Why would I do this? Well, I like to print without supports sometimes, and this is going to give me flat bases to orient onto the print bed. So I want to capture the highest point of everything, which would be your cusp tips, your incisal edges. That looks good. And T for transform. Great. Now remember, this did not change the interior of this. If I was to look now, everything is still the same on the interior. It's just giving me a big flat base because now I want to import some articulation pins. Okay, and the reason for that is to index this properly in the right position. So import append. I've got some articulation pins that I've made in Meshmixer. There's different ones available online. You can get them out of Exocad. Lots of different options on these. But what I'll do is Control select both of them, T, and I want to get these up to where they're more or less parallel with what I'm trying to make here. There we go. And then slide it up to where the pin is going to be about even with the slot for creating this. So accept that. Now they're both still selected, so let's duplicate that. You're going to have at least a tripod of these to actually index anything into place. So let's pull one over here. See if it needs to come up or down any. You can use your arrows, but you cannot use any of the rotational widgets because these things need to maintain perfect parallelism amongst each other. Okay, so that looks good. Duplicate and T. As long as I'm just using the long arrows and not doing any rotating, everything should stay in perfect parallel between these pins. All right, cool. We got that. Let's accept it. Now what we need to do is combine all of these. Okay, so if I select this lower half and then bottom pins, so I'm going to Control select the lower half and all of the bottoms and combine them. Then I'll select this one, combine them. Now they're all considered one STL file, and I can now connect the two. So how do you connect them? Select T. If you hear that noise, that is my dog. That is not me. All right, so clear that selection. Now just do it again over here. T. And I'm just pulling out some extensions or some connectors between these portions. Accept. Clear. Select. T. All right. Accept that. Now let's go to the bottom. Exact same process. Select T. Oops. Now see how I need to deselect this. I don't know how that got selected, but now T. You always got to make sure that you don't accidentally have more than you need to selected, because then you're dragging off parts for things that you're really not wanting to create. So always clear selection and then start a new one. T. There we go. We're all connected now. Accept this. And the whole purpose of even dragging up this base here was just so I could pull a plane cut across everything. So let's first run an analysis on it. That all looks good. And hopefully now I can plane cut. Yes, and you can see that makes a nice solid model. I'll pull it straight across, more or less even with the line between my two halves. And of course I forgot to connect one of these. Let's do that real quick. Select T. Try this again. Edit, plain cut. There we go. Now let's go to the top half. Edit, plain cut. Here we go. Now we have a mold that does not take up that much volume. I could print this on most printers supportless with the base oriented downward. Print this up. It's going to have indexing pins here that position everything into the right place. I'll look at the top now. Same thing. This can go flat without support material. We directly print this, so there's nothing to clean up. And now to inject this, we simply go over and we mix our color of acrylic or bisacryl or whatever composite of choice, inject it into this hole. When we see it extrude out this hole, we know it's completely filled. Rubber band this together, throw it in a pressure pot, and let this set up. And when you open this up, you should have a very accurate monolithic temporary made out of it. So I hope you found that helpful and not too consuming. And that's it.